Hey everyone! So I am going to do this next section, again, not in front of the camera so that you are able to see everything. What we are doing here is solving equations for a variable. Now, if you look at this, you will see that there's not actually any variables listed per se. And that's because in this section, all of your teachers, we want to focus on you actually knowing how to solve for whatever you are given, whether it is a variable or a symbol or whatever it is, okay? So for this first one, we have 4% plus 2 pound, no, that's not a hashtag, equals at, and we are solving for the percent. So for this question, let's split the page in half so our equation is on the left and steps are on the right. Please take note that it is crucial that when you are solving these, that you always list the word of equality. You are not just wanting to do it as this name, you want to make sure that it says of equality or of inequality, okay? So for this first one, we are listing it and solving for the percent. So draw a line right down the middle. Now we have 4% plus 2 pound equals at, and again, we are solving for the percent. My advice would be to circle the percent sign so you know to leave that alone because that's what you are looking to do. So again, we draw our line. Since this plus 2 pound is next to it, we want to move it to the other side. So we are going to jump the line, change the sign. Since it's a positive, when we jump the line, it will now become a negative, which means we are subtracting. So we have the subtraction property of equality. It's as simple as that. Next, what you are going to do is, since the 4 is attached to the percent, remember that when a number is attached to a variable or a number is attached to a symbol, that it means that they are multiplying. So we have to undo that. So we are going to divide it out, since dividing is the opposite of multiplying. So we are going to divide everything by 4 for our next phase, which you will see then down here. That gets our percent sign alone, and we end up with at minus 2 pound divided by 4. So that is the division property of equality, okay? Hopefully you guys understood that first one, and we're going to do another one now. So let's take a look at this one. We have solved the equation. 4 triangle minus 3 circle equals 6 square, and we are solving for circle. So this is our given equation. So now we are going to take that given equation and draw a line down the middle of each of them. And our goal is to get the circle by itself. So if we are looking at that, I am going to circle the circle so it stands out and I know not to touch it. Now, this is currently a positive 4 triangle. So I want to move it over to here. So I'm going to jump the line and change the sign. Feel free to shout it out if you're watching the video and want to do it with it. That's fine. So we are now subtracting 4 triangle. So again, that is subtraction property of equality. Again, we are using equality because it is an equal sign in the middle. If it was an inequality, you would use the inequality statement. Cool, so now that we're there, we've taken care of that part of it. Well, let's look here. We have a negative 3 being multiplied by the circle. So we need to undo that. Well, what is the opposite of multiply? Divide, good. So we are going to divide out negative 3. So if I were moving to this part, it would be dividing by negative 3 from everything. When I do that, this cancels and I'll be left with just my circle. Equals, I have a positive and a negative, so that is now a negative. I have 6 square plus 4 triangle over 3. That is known as the division property of equality. Now, I can technically simplify this again, and that would be done, and if it's a select all, I would be very aware of this, by, you would see negative 6 square over 3 plus 4 triangle over 3. And if you're looking at this, your negative 6 over 3 can then be totally reduced and become just a negative 2 square plus 4 triangle over 3, where only this portion would be over 3, okay? And again, that's the division property of equality. Last but not least, we're going to go over an inequality part, and you're going to see a small mistake on here that we are going to correct as we go. It's not really a mistake, it's more of, I want you to be able to figure out what is missing, okay? So it's one of those like gotcha activities. So So we have inequalities, and we are going to operate with this the exact same way. Okay? So if you are looking at this, right away, you should be able to determine where is the quote-unquote mistake. What do you think it is? Take a second, talk with your partners. All right, we'll address that mistake in just a minute, and let's see if you had it right. So if we are looking at inequalities, we are starting off with -4 times the quantity of 6x plus 2 minus 20 is less than 12. So again, that is our given. So first thing we need to do is simplify this. Well, if you see parentheses, what do you think you have to do? Good, distribute. We all know that you said it even though you weren't actually saying it out loud. So we are going to distribute. So -4 times 6x becomes -24x. -4 times +2 is -8. And then we just rewrite our -20 are less than and 12. Again, distributive property. But what's the issue? Right, it should say distributive property of inequality. Very good. So now I am going to simplify or combine like terms. Remember that when you are doing this, anything that can combine or has the same quote-unquote last name or ending can go together. So nothing can go with -24x, so that's there. -8, -20 will combine to become -28. And then you have the less than 12. So again, combine like terms. Okay? And we can say on there of inequality. Although for that one, it's not really necessary. So now, what would I need to do next? Well, if you recall from when we were doing equations, we drew a line and we wanted our variables on the left, numbers on the right. You always want that protocol, especially with inequalities, because it makes it a lot easier to solve for. So I am going to take this -28 and I am going to jump the line, and that's right, change the sign. So I am going to add 28. And when I do that, it becomes the addition property of inequality. And again, we're only putting that of inequality because it's an inequality symbol. So here is the next part of -24x is less than 40. All right, so our next phase is how do I get the x by itself if it's currently attached to the -24? Well, numbers and variables touching, those are multiplying, so we do the opposite by dividing. So again, look, division property. So we are going to divide out that -24. And when we do that, we are able to simplify it, and we get -3x is less than 5. How did we get to that? Was that really the case? Or what did we actually divide by? That's right, we divided it by 8. So we're not really dividing it by the whole -24, and that's because we are trying to avoid it becoming an actual decimal. So to simplify it, we are going to do it by -8. So -24 divided by -8, we'll leave it as a +8 for right now, becomes a -3x, okay? Negative and a positive is still a negative, less than, and then we have 40 divided by 8, okay? And that's 5. Okay, there's a reason for not dividing it by the negative just yet, and that's because I want to remind you of one key thing. Now, okay, if we are next going to again do the division property of inequality, let me write that in there. Okay, and here we are dividing by a negative. Okay, now if you recall, what happens when we divide an inequality by a negative? What do you think it is? That's right, we have to flip our sign. So since we divided it by a negative here, we have to remember to flip our sign. So when we divide, our negatives will cancel out on this side, however, it is still present here, and we had to flip our inequality symbol. Now, when we are solving this, we are saying, okay, now x is greater than -5/3. Well, that is between -1 and -2. It is an open circle because there's not an equal to sign underneath. And then because of the direction of our arrow, which is our inequality symbol, that is the way we would shade it to the right. Okay? Good job, everybody.